My name's FHWA. I'm with DBI Services out of Hazleton, Pennsylvania. I'm the Market Development Manager for the high friction surfacing and the AMAC Global. We're out here today to perform a high friction surfacing pilot project on State Road 20. We're going to install a resin-based adhesive and apply a calcined bauxite aggregate to increase the friction of the pavement here in an attempt to reduce the off-the-road accidents that are happening in this curve. The aggregate's special because it's very hard and has what's called a high polished stone value. It doesn't get slick, it stays sharp and aggressive. And that's what increases the friction between the car's tires and the roadway surface.
High friction surfacing has its origins actually in the United Kingdom, in England. It was conceived in the mid-70s by the then English government, the Highway Transportation Industry and also Transport Research Lab, which is a government-owned lab, primarily used for roundabouts, which are horizontal curves. That technology transferred itself throughout the European continent to be used on intersections, horizontal curves, and anywhere there was a braking required, an aggressive braking, to add friction in site-specific areas. Okay, high friction surfacing is sometimes called anti-skid in Europe. Here in the US we call it high friction surfacing primarily because we install it in areas where high friction is required on demand. Any area where somebody's going to be braking quite harshly. High friction surfacing is now used in about 18 states currently in the US and is part of the EDC2 Counts, Everyday Counts program funded by the Federal Highway Administration. That is a funded program throughout the US, all 50 states and Puerto Rico, to add safety as a low-cost feature to state highway safety programs. So this is called a low-cost safety countermeasure.
When a person considers this product as an overlay product, the cost seems exorbitant. It ranges from $25 to $35 a square yard. But one really needs to look at it as a crash mitigation product. For example, where these go are generally rural two-lane high-speed curves in which we have no right-of-way. Sometimes we might even be under an occupied right-of-way situation. We can't change the roadway geometry. Super elevation is out of the question. And when you compare purchasing right-of-way to your other treatments, now this becomes very, very economical. Even when you consider, say, guardrail or cable barrier, you can lay this product down and prevent the collisions, where guardrail and cable barrier doesn't actually prevent the collision, it just kind of mitigates the injury after it happens. So this is a good cost savings product when compared to all your other curve mitigation technologies that are available to you out of your tool bag.
We've done pilot projects and statewide projects in several locations. We did over 200 sites for the state of Kentucky a couple of years ago, and the studies there show anywhere from a 65% to almost 100% reduction in the crashes and accidents that they happen. One of the unique things about what we do is we do a full mechanical application. Everything's done by the truck. The truck holds over 1,000 gallons of the resin and about 40,000 pounds of the aggregate. It has a special pump system mounted on it and an application bar where it lays an even film of the resin the full width of the roadway. And then immediately after the resin's laid, it applies the high friction aggregate, the calcined bauxite, in a smooth, even layer and saturates the resin. It's a four-man operation running the truck. We have a driver that's actually steering the vehicle, and then an operator that's controlling the pump and application systems, and then two guys on the back of the truck making sure that the aggregate stays even and is coming out and any of the wet spots are covered as we move down the road. The truck operates at about 26 feet a minute when it's going. It has enough material in it to cover about 2,600 square yards of application in a single run. The current old school application is manual. The resin's placed out on the ground, mixed on the side of the road, spread out, then gentlemen with squeegees come and spread that resin out, trying to get it into an even film across the road. And then they broadcast the aggregate onto it. So it's a slow manual operation. A good manual crew in a 10-hour day can install somewhere between 1,200 and maybe 1,500 square yards in a 10-hour shift. This truck will lay 2,600 square yards in about an hour and 15 minutes. The resin is a hybrid polymer resin, polyester based, that we're using here. It has an advantage over the historical epoxies in that it's more flexible with time. We can adjust the cure rate to suit the ambient temperatures in the application, where epoxies you can't really install below about 55 degrees. We can install this much cooler and still get the cure times and the strengths out of the material that we would typically get out of an epoxy resin system.
The service life of this product is estimated to be between 5 and 10 years. Most of the time you do get the 10 years. I've seen studies where 90% of the material is still in place and providing good friction numbers, even in the 10-year range. From a collision point of view, it usually takes a minimum of 3 years after the fact before we can determine if we're truly getting a crash reduction. So what we'll do is let this product sit down for 3 years, look at the collisions before and after, apply some statistical regression to it, and see what kind of product we have for Oklahoma.